2.5 is on segment lengths in a circle. So the first one that we have is where we had segments that intersected on the inside of a circle. So in the last section, we talked about what we would do with angle measurements. So angle measurements, remember we took the outer arc and the inner arc, and then this part right here was half of the sum of those two arcs. Okay, well, now we're doing segment measurements. So this is different. Do you guys all see how it's different? We're talking about, like, finding something like this length here. Okay, so it's not the same idea as the last one. It's the same picture, but we're finding something totally different, segment lengths, okay? So the way that this works is actually pretty straightforward. So basically it works out so that, I don't know if I want to, let's use X, Y, Z, and W. It works out so that the pieces that are along the same chord, so what pieces are on this chord right here? What two letters? Y and W. If you multiply those together, it works out to be the pieces that are on the product of the pieces on this chord. X, Z. Does that make sense? So we're going to have Y times W equals X times Z. Isn't that nice that it works out that way? Yes.
Can Y equal Z and X equal W?
Not necessarily, and you can tell that they look like different lengths, right? Like X and Y look different. Z does kind of look like Y, but not necessarily the same lengths. Yeah.
So why is it times instead of plus? Like if you added.
Because we're not doing the angle measurements anymore, right? That was where we did half the sum of the two arcs. We're doing segment lengths now. So we're not doing like the angle measurement here equals half the sum of these two. We're now talking about segments. It's totally different. All right, so let's try it on this next one. Get rid of my arcs there. All right, so it says chords A, B, and CD intersect inside the circle. Find the value of X. So we're going to do 20 times X equals 5 times 16. Perfect. So I get 20X equals 80. So then X is 4. All right, so this next one, so we have X times what number? 15 equals 10 times X plus 1. So we get 15X equals 10X plus 10. So we get 5X equals 10, so X is 2. Yep, perfect. Now be careful, this says find CD though, so what's CD? 17, because it's 2 plus 15, right? All right, perfect. You guys understand that one? That's pretty easy, isn't it? All right, so you might have a tangent segment, a segment that's tangent to the circle at its endpoint. That would be something like, this would be the tangent line, right? Well, what if we don't have the whole line? What if we just had the tangent segment? We could also have a secant segment. This would be a secant segment. And we have an external segment. So this would be an external segment because it's on the outside of the circle. And so with the tangent segment also is an external segment because it's on the outside of the circle. Does that make sense? Do you guys see where there's an internal segment? Yeah, this would be interior or internal. Exactly. So we use words that make sense. So this is an exterior. Okay, so there's kind of a complicated definition, and every single geometry teacher I've ever met, the first time they did this, they messed it up. So I remember there's a teacher at our school, Mrs. Summitman, who mostly teaches science now, but when she was hired, she taught geometry. And she did this on Grandparents' Day and taught the whole lesson the wrong way, and then realized it in the last 5 minutes of class and was like, oh my God, I just taught this wrong in front of all of these grandparents. So every teacher has been there. And she came to me and she was like, I just taught something totally wrong in the circles chapter. I said, oh, was it outside times whole equals outside times whole? She was like, yeah, it was that. So here's the problem that geometry teachers and you might make. So we just learned this cool thing where we were like, oh, X times Z equals Y times W, right? But on this, it's not this times this equals this times this. It doesn't work that way. Okay, so if you read through the definition, it's a very confusing definition. It says if two secant segments share the same endpoint outside of a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. That's a mouthful. So what I want you guys to remember is that the outside times the whole is equal to the outside times the whole. And this will work for all of these ones where it's meeting on the outside of the circle, where they intersect on the outside. So in this case, this would be the outside, EA. What's the whole thing? What's this whole secant segment? EB, right? That's times EB. Equals, well, what's the outside of the next one? EC. And what's the whole thing? Yeah, ED. So be careful. It's outside times whole equals outside times whole. Don't just do the pieces. That is the biggest mistake people make. They're always like, oh, EA times AB. That'd be nice if it was like that, but it's not. That's not the rule, okay? So we'll do outside times whole equals outside times whole. So if we have something like this, it's still outside times whole equals outside times whole. But this is a little bit different. Do you guys see what's kind of messed up with this picture? It doesn't have like the whole thing, right? It doesn't have any part that's interior for this line. So when I say outside, it's definitely EA, but what about the whole? It's itself, EA, that's right. It's also the whole. The outside and the whole are the same. So how about this side? EC times, yep, ED, perfect. Outside times whole equals outside times whole. Okay, so let's try to apply this. Don't mess it up. So we have outside times whole equals outside times whole. So set up the equation. See if you guys can set it up, and then I'll see if you're right. So we have the outside and the whole, right? 12 times 12. And then we have the outside. But what is the whole length here?
10 times x plus 1.
Close, but it's not times. 10 plus x plus 1. Well, what is 10 added to x plus 1? X plus 11. That's our whole. So be careful. Don't multiply them. We got to think about what that whole length is. Like segment addition postulate, right? We have to add the two pieces together. So add for the whole. All right, so we get 144 equals 10x plus 110. We subtract the 110 over. So we get 34 equals 10x, and we divide by 10. So x equals 3.4. All right, so how about the next one? X times, well, we have the whole thing drawn in, right? That whole thing is 72. Equals 40 times 78. Now be careful though, if I didn't have 78 and instead I had the inside piece was 38, then I'd have to do 38 plus 4 to get the whole thing, right? So 40 times 78 is 3,120. So I have 72x equals 3,120. So when I divide by 72, I get x equals 43.3 repeating. If you wanted to write it as a fraction, you could. You could do math 1, and you could say 130 over 3. That's the same thing. But 43.3 repeating is fine. Just make sure you do your repeating sign. All right, is this making sense? All right, uh-oh. I have something in a box talking about quadratic formula.
Oh.
Yikes. Sometimes these will have the quadratic formula. So this happens when you have a variable that's on the outside. So if you remember the quadratic formula, does everybody remember what it is? Try to write it down. I should show you the quadratic formula songs. Remind me about that. Oh, but do you know it to get low? There's a quadratic formula song to get low. I know. There's a lot of weird math songs that you can find. I know. It's pretty exciting. It's much better than Pop Goes the Weasel. All right, so yeah, you should have negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we got a lot of things going on here. So one thing that we have is that they're intersecting on the inside of a circle. So with these red lines, So let's go back to the ones when we were talking about inside. Did we forget that one already? So we should have 3 times 14 equals, 3 times 14 equals x times 6. Perfect. So 3 times 14 is 42 equals 6x. So x is equal to 7. So we got that right away. Now we got to do the outside times whole thing. So how do I set up this equation? Yeah, so because we know that's 7, right? So we could use that. So this whole thing is 13. So we have outside is y times the whole. Well, it's 13 plus y, right? So let's write y times 13 plus y equals outside times whole. So on the other one, 8 times 8 itself. So we get 13y plus y squared equals 64. And we recognize that we have both y squared and y in an equation. And they don't go away if we can't like subtract 13y from both sides and it like goes away, right? It doesn't happen. So we get everything on one side. So I have y squared plus 13y, and I subtract that 64 to the left side, so equals 0. And then you could try to factor, but I don't think this one does factor. Does this one factor? I don't think it works. So we have to use the quadratic formula.
Yes.
Oh, super exciting. I'm sure you guys are all pumped. So I get y equals negative b, so negative 13, plus or minus the square root of b squared. So what's 13 squared? Minus 4 times 1 times 64 all over 2 times 1. Uh-oh, this one may not work. Oh, negative 64, isn't it? Dang, I forgot my negative. Okay, so I have 169 minus 4 times 1 times negative 64. So all inside there, I get the square root of 425. Okay, so in geometry, we're not too picky. Like usually, I'm guessing if Math Excel had this, they would let you round to the nearest 10th. So we're going to round to the nearest 10th. So I could make you simplify, using your simplified radicals and so on, but I won't be that mean. So the square root of 425 is 20.616. So let's write that. So I have negative 13 plus or minus 20.616 all over 2. And there's 2 answers that I can get. So let's first take the negative 13 and do plus 20.616, and then hit enter, and then divide by 2. So the first answer I got when I did the positive was 3.808, so I'm going to do 3.8. And the second one, if I take negative 13 and then I do minus 20.616, and then I take that answer and I divide by 2, I get negative 16.8. Okay, look at the picture. Can y be negative in the picture? No, that's a length. It can't be negative, so cross that one out. So our answer is only 3.8. But sometimes it could be more than one thing, so you might have 2 answers. Okay, are we feeling okay with that? Just because it went to quadratic formula, you guys were like, no.